I am Makoto Tsujimoto. My research field is fire safety engineering. This site is Kyoto Animation Company, which had a severe fire on 18th July 2019. 36 people died. In this fire, the smoke movement, how the smoke spread inside the building, remains a key issue. But it is not practical to make an experiment at the same size of fired building. This video is an introduction of small-scale experiments to recreate the smoke movement in real-size building, and the theory of scale law, which relates the scale and heat release rate. These experiments were done about 30 years ago, so the quality of video is not good. This video is not a common explanation of pi number like Reynolds number or Froude number. I will explain the technology which makes the smoke movement in reduced size appear as though in real scale movement by replaying the video in slow motion. For example, this film of the symbol monkey is replayed in 10% speed, so it takes a time in 10 times. This film is replayed in normal speed. Backgrounds were changed. Don't you feel that the monkey moving slowly looks like bigger than the normal one? Using this logic, small-scale experiments were done to find out how the smoke spread changes depending on the position of fire origin and the opening in the atrium of high-rise apartment. This apartment is shown in the right edge of the slide. Previous analysis showed that the smoke spread becomes similar in case that the ratio of heat release rate is 5 seconds power of size ratio, and that time warping is square root of size ratio. Scale of two experiments is 2.5, and please remember square root of 2.5 is 1.58. These are two different size models we used. We called small one Mahjong die, which is a table for playing Mahjong, and big one Yojohan, which is 2.7 meter square room. The size ratio is 2.5. These are burners and so on to control the combustion. This is the schematics of the atrium, which is the object of the experiment, and it has the vertically long openings colored blue. These figures show the condition of experiments. The first experiment, which has no opening. Left part of the screen shows the smoke spread in bigger model Yojohan, and the right side Mahjong die. The scale difference of left and right side is twice and a half, so the distances from a camera to a model were controlled to match up the viewing angle. The ratio of heat release rate is about 10. To synchronize the smoke movement, the video of the right side is replayed in 63%, so the time display on the bottom right corner changes slower than the normal time. because the laser beam for visualization is weak on the left. It is hard to identify, but you can realize that the movement of smoke layers on both sides are similar. The next experiment. Atrium has vertically long two openings. The depth of smoke layer increases like last experiments, but because of vertical opening, smoke is exhausted, and the lower end of smoke layer becomes stable at the same level on both sides. The final experiment. The difference from the last experiment is only the position of fire source. We just moved the fire source to the center of the atrium with no attempt, but something unexpected happened. Because the position of two openings is point symmetric dimensionally, the airflow into the atrium causes a rotating flow, and it grows up to a fire wheel after a while. On the right side, a fire wheel starts at 27 seconds, and on the left side it happened around the same time. It shows the scaling law we used is useful to predict the smoke movement in an atrium, because even the moment when the fire wheel breaks out agrees with two different side experiments.